So you know that feeling, right?
Oh, I think everyone does.
You're working with a generative AI, maybe ChatGPT, maybe something more powerful, and you ask it to do something.
Draft a summary, write some code.
Exactly. And the first time, it's just brilliant. It's perfect. Then you try the exact same prompt an hour later, and what you get back is, well, it's a mess.
It's totally inconsistent, rambling,
Yeah.
sometimes just plain wrong.
It feels like you're just rolling the dice every time.
And that inconsistency is really the central problem we're all facing with LLMs right now.
Mm.
It doesn't matter how big or sophisticated the model is.
Right.
Our sources show that the line between a perfect output and a dud can be something as small as a misplaced comma or a missing detail in the input.
And that frustrating randomness is exactly why we need to get more rigorous about this. We need to move beyond just, writing prompts. Which brings us to the core of this deep dive, prompt optimization. This isn't just about tweaking a few words. It's a systematic, almost scientific practice of refining your input to get consistently better results. And for you, listening, this deep dive is the shortcut to getting there.
Exactly. And to start, we really have to define what we mean.
Okay, let's do it.
So prompt optimization is really the process of improving the structure, the content, and the clarity of a prompt, all to enhance the model's response.
So it's not just the words.
Not at all. It sits right at the intersection of prompt engineering, iteration, and really understanding the task you're trying to accomplish.
I feel like people use prompt optimization and prompt engineering almost interchangeably.
They do, and it causes a lot of confusion.
So what's the real difference? For our listener who's already pretty deep in this space, it can sound a bit like semantics.
It's definitely more than semantics. There are different stages of the whole process. Think of prompt engineering as creating the blueprint. You're designing the prompt structure from scratch.
So that's where you use foundational techniques like giving the model examples, few-shot prompting.
Right, or using chain of thought reasoning, specific formatting, all of that initial design work.
So engineering is the initial design, then optimization is like the performance review.
Precisely. Prompt optimization is the refinement. It's the tuning of an existing prompt to improve its performance over and over again. It's much more focused on iterative testing, on evaluating the output, and using actual metrics.
It's less art and more science.
A lot more science.
That focus on data seems really key here. The sources we looked at are clear that this whole optimization process is super systematic.
It has to be. You start by benchmarking the original prompt to get a real baseline.
You have to know where you're starting from.
Exactly. And then you get into that critical feedback loop. You evaluate the outputs, either with human judgment or, automated metrics.
And that feedback is what tells you what to adjust.
Right. Is it clarity? Is it structure? Specificity? And then you test again, ideally on a good data set. The end goal is to create a reusable template so you can actually scale what works.
And the economic argument for doing all this is, well, it's pretty powerful. This is crucial when things like speed or cost are a factor.
Oh, absolutely. API pricing is almost always tied to token usage.
Right.
So making a prompt more precise and succinct directly translates to lower API costs when you're deploying this stuff at scale.
So we're talking real money here.
We are. One study we saw showed that for high-volume tasks, just shaving off a few unnecessary tokens per prompt can save hundreds of thousands of dollars a year.
Wow.
Which is why that automated feedback-driven optimization is becoming pretty much mandatory in any serious deployment.
So if we connect this to the bigger picture, prompt optimization isn't just a nice to have.
No, it's foundational. It's absolutely foundational if you want to build production-ready AI.
It all comes down to reliability and trust, doesn't it?
It really does. The research shows over and over that this kind of deliberate, data-driven optimization seriously enhances performance, especially for tasks that need, domain-specific accuracy or nuanced reasoning.
Without it, you're just getting generic responses. You're letting the model kind of wander around in its own knowledge base.
You are. Optimization is what guides it away from that noise and towards precise, valuable, context-aware answers.
I have a question about that, though. If I spend all this time perfecting one prompt for one specific model, doesn't all that work just get wiped out the next time the model gets updated? Am I just creating a brittle prompt?
That is a sharp and a very necessary question.
Yeah.
And it forces us to focus on the process of optimization, not just the final text.
Okay.
Because good optimization also builds in efficiency. For example, that work by Choi you mentioned earlier, it used a framework that actively optimized to minimize unnecessary token usage while still boosting relevance.
So it's not just about getting the right answer. It's about getting the right answer efficiently without the model having to, churn through extra steps or generate a wordy output.
Exactly. It's the difference between a high-efficiency engine and one that just sputters and burns fuel. And for complex tasks, structure is everything.
Like math problems.
Math problems, complex decision-making, yeah. Requiring that step-by-step thinking, it unlocks performance gains you just can't get otherwise.
And then finally, there's scalability.
Right. In an enterprise setting, you can't have a person manually tweaking every single prompt.
It's impossible.
So these automated heuristic methods are turning what used to be manual trial and error into an intelligent, scalable pipeline, which is vital for things like compliance and just predictable performance.
Okay, now for the really fun part. The specific, structured strategies you can use right now to get better outputs. We need to go beyond just saying, be more clear, and talk about how.
Absolutely. The first big lesson from the research is the power of structure. And that means prompt template design.
So don't just type a sentence.
No. Use a standardized format.
Ugh.
A systematic analysis we saw confirmed that the template structure itself has a huge impact on how well the model follows instructions.
So instead of just writing, summarize this memo for the exec team in a serious tone, you'd build a template.
Right, with label sections like task, summarize, audience, executive team, tone, formal.
You're forcing clarity on it.
You're forcing clarity and reproducibility.
Yeah.
It constrains the model in a really productive way.
I like that.
Strategy 2 is something called Content Format Integrated Optimization, or CFPO.
Okay.
This basically recognizes that the model was trained on text that has formatting. Bolding, bullet points, headers.
It understands structure.
It does. And the research shows that optimizing both the content and the formatting, like bolding keywords or using numbered lists, gives you better results than just tweaking the words alone.
That's fascinating. It's like you're speaking the model's native language, which is markdown and structure.
It really is.
Yeah.
Now, strategy 3 is probably the powerhouse for complex tasks, combining few-shot examples with chain of thought.
So giving it an example of an input and output, but also showing the steps to get there.
Exactly. We know they work well on their own, but when you combine them, when you show the model examples of the reasoning process, you see this huge improvement, especially in things like coding or common sense reasoning. It learns the process.
Strategy 4 sounds like something from science fiction, meta-prompting, and LLM-driven refinement.
This is where the AI starts helping itself.
Okay, explain that.
So instead of you manually testing variations, you use a primary prompt and meta prompt to ask the LLM itself to suggest improvements to your original prompt based on the bad outputs it just made.
Whoa!
Yeah. You can ask what instructions were missing in the last attempt that caused you to fail, and it will tell you.
And then it refines the prompt automatically.
It can, yeah. These feedback loops can achieve scalable refinement without a ton of human input. It completely closes the loop.
Which feeds right into strategy 5, which is all about iterative evaluation and metrics.
It has to be a data-driven cycle. You have to benchmark your prompt variations against objective metrics. Accuracy, relevance, whatever matters for your task.
And this can all be automated.
The whole cycle can. Variation, measurement, refinement. It takes the guesswork out of it. And for really complex workflows, that leads to the final strategy, number 6. Automated multi-step task frameworks.
For when one prompt's output is the next prompt's input.
Exactly. If step 1 fails, the whole chain is corrupted. So frameworks like prompts use scoring and human feedback to optimize the prompt at each sequential step. You're optimizing the entire flow.
That's incredibly powerful. But while these strategies are great, we have to talk about the common mistakes.
Oh, absolutely. Because even very sophisticated users can get tripped up by small things that just tank performance.
So what are the biggest errors that just negate all this hard work?
The fall number 1 is the simplest and honestly the most common, being too vague.
Just not being specific enough.
Right. If you don't define your parameters clearly, the model gives you a generic, off-target result. Asking for an analytical comparison is useless. You have to specify what to compare, using what metrics and what format.
I think I'm often guilty of the opposite problem, which is pitfall 2, overloading the prompt.
Trying to do too much at once.
Yeah. Cramming in too many tasks or tones or instructions, it just confuses the model and you get a fragmented, useless response.
You have to break it down. One prompt, one clear core objective. That's the key.
What's next?
Pitfall 3 goes right back to our strategies, inconsistent formatting. If you start with a strict template, you have to stick to it. If you change how you present your examples or mix your instructions and questions, you degrade the output quality. Consistency is king.
And pitfall 4 feels obvious, but I see it all the time. Skipping iterations.
Yes, optimization is almost never a one-and-done process. If you don't test variations and compare outputs with real metrics, you're leaving so much performance on the table. Good enough isn't good enough for production systems.
And the final one.
Pitfall 5 is ignoring alignment. This is when you get an output that's technically correct, but contextually all wrong.
Like getting a casual email draft when you needed a formal legal memo?
Precisely. Your prompt didn't just fail to specify the task. It failed to align the output with the specific use case and the intended audience.
Okay, let's bring this home. Let's move from the theory to the actual tools and real-world examples that make all this scalable.
Yeah, we need to talk about the platforms that treat prompts like the critical infrastructure they are.
Where do we start?
A great example is Prompt Layer. People describe it as Git for prompts. It's basically a logging and versioning system. It captures every prompt model pair along with metadata like latency, token usage, everything.
So if my developer changes just one word in a prompt.
You can immediately see its impact on cost and speed across thousands of runs.
So it allows you to do real A/B testing on prompts in production.
Exactly. It turns guesswork into engineering. And then you have tools like Human Loop, which is more focused on that rapid feedback-driven cycle.
How does that work?
It lets you test prompts with real-world data and then collect structured human ratings on the output. A person can score the accuracy from 1 to 5, for example.
And you use that feedback to fine-tune.
You fine-tune based on those performance metrics. It's all about rapid iteration with real human signals.
Okay, let's talk about where this has a measurable impact, starting with the high-volume area like customer support.
In customer support, optimized prompts can drastically cut down resolution time. You give the model examples of correct replies, you embed policy constraints, and you minimize hallucinations.
So the replies are accurate and compliant.
And crucially, because it's so high volume, reducing token usage even slightly translates into massive operational savings.
Another huge area has to be enterprise document summarization.
Oh, for sure. Legal and audit teams are using these techniques, meta-prompting few-shot tuning, to make sure that summaries of huge contracts aren't just factually correct, but also stick to a consistent format. The output is immediately usable.
We're also seeing big gains in content generation for marketing.
Yes, structured prompts there are optimized not just for tone, but for things like keyword density and length. You can generate hundreds of product descriptions that are all unique but share the exact same voice and SEO characteristics.
And finally, what about in something like educational tutoring?
There, prompts are optimized to scaffold explanations. They break down complex concepts into step-by-step formats that align with a curriculum, making the LLM a much more predictable and reliable teacher.
So where is all this headed?
Well, as these models keep scaling, prompt optimization is shifting away from being a manual skill. It's moving toward automated, model-driven refinement.
You mean things like reinforcement learning with human feedback?
Exactly. And prompt distillation, meta-prompt evolution, techniques that let models learn how to improve their own prompts based on whether a task succeeds.
So we're moving beyond a person trying to write the perfect prompt.
Right.
To creating a system that automatically builds, tests, and adjusts the perfect prompt based on real-time data.
That's the future. At the system level, you're seeing tighter integration with LLMOps platforms. This is all about dynamic, context-aware, and cost-aware prompt adjustment becoming an invisible core layer of the AI infrastructure.
So what does this all mean for you listening at home?
It means that prompt optimization is the engine behind accurate, efficient, and reliable LLM interactions. And as this moves from a specialized manual skill to a core automated layer of the AI stack, I want you to think about how this trend toward self-optimizing adaptive interfaces fundamentally changes the nature of that input box you see every day. The future of interaction isn't just about what you type. It's about how the AI system is constantly refining that input for you, making every single interaction smarter, better, and cheaper.